The second factor that affects micronutrient availability, and specifically in this case, iron and zinc, but you could think of this for pretty much all the micronutrients, is soil organic matter. And that's because organic matter is simply a source of micronutrients. Micronutrients from organic matter are released to the soil solution when organic matter is mineralized or attacked by microorganisms and degraded into smaller and smaller compounds. This releases micronutrients to the soil solution, including iron and zinc. So, are organic amendments a good source of micronutrients when you apply them to soil? Yes, they are. And organic compounds can actually help chelate micronutrients that may be present in the soil to begin with. What does this mean? The term chelate means claw-like or crab-like. And so the chelate, or the compound that we call a chelate, can come along and grab a hold of a micronutrient and complex it and help to carry it towards a root. So you see this in this illustration here. This is some sort of chelation compound. It's an organic compound, and it has sort of a hole here, or space. And in this case, copper can fit into this space. And so if you see what happens, copper forms a nice association with this chelate. And this chelate can stay in the soil solution and travel from an area of relatively high concentration to low concentration. So, i.e., in the bulk solution towards a root or a root hair, and release the copper to the root itself. This also happens with zinc and to some extent iron. So what does chelate? What does chelate mean? Or what is a chelate? Let's just reiterate this from the previous slide. So it's an organic compound. It forms a complex with metals, and it makes those metals more stable and soluble. The definition means claw-like or crab-like, and there are both synthetic chelates that we as humans can create and utilize in the environment, and there's certainly plenty of biological chelates. And the concept, like illustrated on the previous slide, is pretty simple. You have a metal ion that's in the soil that ends up liking to be either associated with organic materials that are not chelates, or on exchange sites, or adsorbed to the edges of oxides or hydroxides or carbonate minerals, or actually precipitated as mineral phases. And I can tell you that iron and zinc, they don't like being in the soil solution. They like being other places. And so the metal ion can be chelated to form a complex that keeps the metal ion in a solution, or in the soil solution, to be delivered to the plant root. And it works pretty effective. Now, one thing I will point out, and it's maybe hard to see in this picture on the right-hand side, but certainly from the previous slide, that chelates are organic compounds. And that means that they can be attacked by microorganisms in the soil and degraded, so they don't last forever. And that's something just, I think, important to note, as well as keep in the back of your mind.